All right, let's jump right in. We're going to pull back the curtain on Python today. We'll see how a bunch of plain text can become a real working program. We're starting right at square one to see how this stuff actually works.
You ever just stare at a bunch of code and think, how? How does that turn into an app on your phone or a video game or something that crunches huge amounts of data? Well, it's not magic, I promise. It all boils down to a few really simple but super powerful ideas. Let's get into the first one right now. Okay, first up, the atom of code itself, the variable. This is all about how you store your very first piece of information. So our source for this, Bro Code, has this perfect way of putting it. The absolute best way to think about a variable, it's just a container. That's it. Think of it like a box. You slap a label on the box and you put something inside. Simple as that. And this is what it looks like in the wild, in actual code. On the left, you've got your label, right? Name. That's the name of our box. Then the equal sign. That's not equals like in math. It's more like an arrow. It says, take whatever's on the right and stick it in the box on the left. And on the right, we have the text, bro. We put it in quotes so Python knows, hey, this is text. And boom, that's it. You've just made your first variable. All right, so we have these containers. Next question is obvious. What can we actually put in them? These are basically the building materials for your program. Now, this is actually super important because you can do different things with different types of data. I mean, you can do math with numbers, right? But you can't exactly add your name to your age. Python needs to know what it's working with. So here are the big ones. You've got strings, which is just a fancy word for text, integers for your whole numbers, floats for any number with a decimal point, and then there's this little guy, the Boolean. It's like a light switch. It can only ever be true or false. That's it. Okay, so storing one thing is cool. A name, an age, whatever. But real programs are messy. They deal with tons of data at once. Think about a list of all your contacts or a dictionary of words and their definitions. How in the world do you handle all of that? Well, that's where these two heavyweights come in. On the left, you've got a list. The best analogy is right there. It's literally like a shopping list. It's an ordered collection of stuff. You find things by their position, the first item, the second, the third, and so on. But then on the right, you have a dictionary. This is more like a real dictionary. It's a bunch of key value pairs. You don't care about the order. You look up a key, like USA, to get its value, Washington, D.C. Totally different ways of organizing information. Okay, so we can store our data now. Single items, big collections, we're good. But a program that just sits there holding data is, kind of boring. The next step is giving our code a brain. Let's make it smart. And the main tool for that? It's the if statement. Seriously, this is the cornerstone of all logic and programming. All it does is ask a simple true or false question, like, is the age variable greater than 18? If the answer is yes or true, the program goes down one path. If it's no or false, it goes down a completely different one. And this right here shows you exactly how that decision-making process works. It's a sequence. First, the program checks the if condition. Is the age 18 or over? If it's true, it does that thing. And here's the crucial part. It completely ignores everything else. It's done. But if that first condition is false, only then does it move on to check the elif, which just means else if. And if that's false too, well, then it finally lands on the else block, which is kind of like the safety net that catches everything else. Okay, we've got data, we've got logic. Now let's talk about being smart and maybe a little lazy, in a good way. There's this huge principle in coding called don't repeat yourself, or DRY, and functions are how we stay dry. Just look at this. We're printing hello 3 times. Okay, fine, it works, but it's repetitive. Now, just imagine for a second you had to do this 100 times. And then your boss comes over and says, hey, can we change that message to goodbye? Oh man, you'd have to go and manually change every single one of those 100 lines. It's not just a pain, it's practically begging for you to make a mistake. And here is the much, much better way. We make a function. See that def keyword? That means we're defining a new chunk of code, and we're giving it the name hello. Then we just put our print statement inside it. Now, whenever we want to print hello, we don't rewrite the code. We just call our function by name. Hello, hello, hello. And the best part? If we need to change the message to goodbye, we just change it in one spot. So much cleaner. So the really important thing to get here is that none of these ideas live on an island. Variables, data, logic, functions. They're like Lego bricks. They're all designed to snap together to build something way bigger and cooler. Let's see what that looks like.
Check this out. This is a little piece from a quiz game, and it has everything we just talked about. See? We've got a function called check_answer. It takes in two variables, answer and guess. And what does it do inside? It uses our logic engine, an if-else statement, to check if the two are the same. It's all there, all our building blocks working together in just a few lines of code. So let's just boil it all down. It really comes down to these four things, these four pillars of programming. You've got variables to hold your stuff, data types to tell you what kind of stuff it is, control flow, like if statements to make your code smart, and functions to keep your code clean and reusable. That's the core of it right there. And here's the thing. With just these four ideas, you can honestly start building some really cool things right now. A simple calculator? Yep. A little number guessing game? For sure. A text adventure? Absolutely. They all just use these same fundamental pieces. So really, the only question left is the one right here on the screen.